Graph the function f of x equals the square root of x plus 3. Okay, let's first talk about the domain of this function. We have a square root. We know that we cannot take a square root of a negative number. That gives us an imaginary number. We want our answers as real numbers. So anytime you have a root function, if you have an even root, and you have anything under there that involves x, to find the domain, you take that x stuff and you make sure it's not negative. Greater than or equal to 0 means not negative. So I take x plus 3 and I make sure it's not negative, and I solve this. So I get x is greater than or equal to negative 3. That's my domain. Okay, so let's plot some points. Okay, I'm going to try to plug in values so I know the root. I'm going to try to make the inside a perfect square. So I can plug in negative 3. I get negative 3 plus 3 is 0. The square root of 0 is 0. Okay, what if I put in negative 2? Because I can't go any smaller than negative 3. What if I put in negative 2? Negative 2 plus 3 is 1. Square root of 1 is 1. What if I put in, let's see, what if I put in positive 1? I get 1 plus 3 is 4. Square root of 4 is 2. Now I want the inside to equal 9, so let me put in a 6. 6 plus 3 is 9. Square root of 9 is 3. And so on. I could go further. I could make this square root 16. I could put 13. So square root of 13 plus 3, that's square root of 16, which is a 4, and so on. Let's go ahead and plot this. Notice my domain is x is greater than or equal to negative 3. That's a little crooked, but okay. So 1, 2, 3. 1, 2, 3, 4. Okay, so I'm just going to go ahead and start plotting these points. Plug in negative 3, 0. Negative 2, 1. 1, 2. 1, 2, 3, 4, 5, 6, 3, and I can connect this. I get y equal the square root of x plus 3. And we see the domain is x is greater than or equal to 3. This is the domain. What is the range? What y values will we get out of this? Looking at my picture, we see I can never go further than this. My y values will always be 0 or larger. And if you're thinking about the graph of this, I mean, just looking at the function of this, I can get positive values out of this. I can get 0 out of a root, but I can never get a negative. Because if I have a negative under the root, it's not a real number. The only way to have a negative is if there's a negative in front. So there you go. I'm going to show you how to plot this using shifting. So let me get a new page. What was it, plus 3? Okay, we are going to take our parent function, y equals square root of x. We are going to shift it. Since I've replaced x with x plus 3 inside my function, I know it's going to be shifted left or right. Now, it's always counterintuitive if it's shifted left or right. Insiders lie, outsiders tell the truth. So it says x plus 3, plus usually tells us right, but it's backwards, so it's going to be shifted left 3 units. The way I remember it is, what do I have to plug in here to get a 0? Well, I plug in a negative 3 to get 0. Okay. So let's look at our graph. Okay, I'm off a little bit. But So if I look at my original, I plug in 0, I'm plugging into here, 1, 4, and 9, because those are the perfect squares. So 0, 1, 2, and 3, plugging into here. So I plot those. 0, 0, 1, 1, 4, 2, 9, 1, 2, 3, 4, 5, 6, not quite enough, but over here somewhere, it's off my picture, but you get the idea. Then I take every one of these points and I shift it left. 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. And this is y equals square root of x plus 3. This guy was y equal root x. That make sense?